click on add, give the position to be 0 to let's suppose it is 3.3, it will be around 1.6 the maximum edge point, and the step size it might be 0.2 mm. So what it will do now is, starting from 0 till 1.6 mm with a step size of 0.2, that is for each 0.2 mm a result will be simulated here. So from this we can find out in which particular position my S parameter, that is my reflection coefficient, is very minimal. So at that point I can take it as my matching of 50 ohm is exactly done there. So once we click OK and go for simulation, we can validate and just click on analyze all. Now here almost 9 simulations will be running at a time. Just it is kind of an each and every time changing that particular parameter. We are just running it in a single stretch. That's it. So let this get simulated. I'll let you know. You will get an idea after seeing that reflection coefficient how this position makes an impact on my design there.
The parametric analysis, you need to give it in parameters.
Yeah, it should be,
it should be in parameters.
Defined in parameters. So you can see at 0.6 the matching is exactly been the impedance matching is happening exactly. So the reflection coefficient, it is very minimal in this case. Okay, so we had took this particular, which is around 28 gigahertz, the frequency of operation, or the resonance frequency is exactly matching around for 50 ohms, it is around 28 gigahertz. Let's suppose this antenna we had designed, and other than that, if you want to go for radiation or field distribution, how it is happening, it is similar, just like that. You can select this particular geometry, that is my radiator, which is the rectangle 2. Right click, go to plot fields. You can go for, first you can just check with surface current. So let's suppose vector JSurf, then done. Once we zoom in, actually the nominal value
progress, then minimize this one. Message manager.
yeah.
That components of it.
Sankar, can you sit here? No, actually this reflection is not, reflection come more.
Come here, in the check. Okay. You want to take this?
Yeah.
Why you go for that?
Okay, this here. Coming correct here.
Now it is clear, na?
No, it's clear.
You go somewhere like this.
Oh, okay. It's not related to movie recording, okay?
If I show you, let's run for 0.6. Okay, now you can see the field surface current distribution from port. It is distributing overall to my patch here. Okay, the same way you can plot. This is similar to the field plotting. So here, similarly, you can select the perfect T, which is rectangle 2.
Progress.
So again, once you right click on that particular geometry, go to assign field, you can go for again E field and H field. Mostly it will be 90-degree perpendicular to each other. So if it is along y axis, if E field is along y axis, y should be along x axis. So in that way you can just go ahead with this analysis. And last, nothing but this is like whatever the signal we are sending. Let's suppose from a mic, if we are giving a voice as a signal, that signal it will be transferred into an electrical signal by mic, and that electrical signal will be amplified by an amplifier. Then using a phase shifter or something, it will be given as an input to this particular terminal which we had created. Okay, so that particular signal, whatever it has reached the port, we had checked first like whether that whatever the signal it has reached, is it the whole signal is reaching properly to my radiator or not. Okay, that was about reflection coefficient. If the reflection coefficient is not neglected, like if it is not matched or the impedance is mismatching, because of reflection coefficient, whatever the Y signal I had sent as an electrical signal, nothing is going to be transmitted to the other end. So the first criteria was whatever the signal I am sending, is it reaching my radiator properly or not? That was the thing which we are seeing there. Okay, and then once it got confirmed like reflection coefficient is minimal at that frequency, then the next point is whether it is being distributed properly on the surface as a surface current or not. That we have visualized using this. Okay, the maximum amount of current whatever it is reaching to the radiator, it is getting distributed properly. Then the next, then you can go in this, or else you can go to result, create report, you can see far field, and you can choose 3D polar here. Here I'll just make it as dB. Here it is 3D here right now. Once I click on new report, you can see the maximum radiation which is coming out is along Z direction, and the maximum gain which we have got is 7.36 dB. So this is for single element which we have made. Let's suppose we are going for array creation. Okay, so
Sir, can we plot the realized gain here?
Sir,
Realized gain?
we can plot it. You will be having lots of parameters. Just as an general case, I am giving it.
Okay.
Once you go for far field, you can go for you can see a realized gain.
Okay.
You can plot anything. Just I am showing only a part of it.
Okay.
Mostly you will be familiarized of it. Other than that, if you want to go for 2D plot, you have antenna parameters separately.
Okay.
Create antenna parameters report. Again, for rectangular plot, you can see all the antenna parameters which is needed, peak directivity, peak gain, whatever you want to measure, you can go ahead with this. For your system, whichever parameter you want to go for, you can go in this.
Okay.
And just to showcase, just as a general introduction, like how in a physical way we send the signal and how it gets radiated as a basic concept. And if we are deep diving into analysis, each and every parameter you can showcase. So then the next part will be antenna array creation. Okay, let's suppose we had created this antenna. Just I will make a copy of this.
What about the optimizations?
Optimizations, you have lots of schemes in this. Once you go to
There are different types of really that adapt to that.
you can choose different types of schemes here. This is nothing but generally a kind of algorithm for each and every kind of optimization. In this, you can set up a calculation which particular parameter you have to set it. For example, I am clicking it as add calculation. In this, you need to set a goal like what should be the maximum. Is it in this particular case at this particular frequency? What should be my maximum like minimum goal? That you have to set it, and it should be whether it should be less than or equal to or less than or minus. Based on that, what it will do is automatically it will give you the parameters of it. It will optimize it. It will change all the parameters of your design, and it will say like for this if you need this particular result, this should be the width of your patch, or this should be length of your patch, or substrate size. It will change automatically. It will optimize, and it will give you the results based on that. Other than that, Yeah.
The algorithm is like we have to choose on our own.
Yeah, which kind of algorithm we are going to go for. And other than that, if you had made any kind of your own algorithm from MATLAB, you can just import it over it.
One algorithm is also we can make that.
Yeah.
But which one is better, sir?
That depends on like
No, not like
What
that.
application you are going for? Again, it depends, sir. So one this particular optimization scheme, let's suppose.
I done optimization. Huh? Last time when you came, I had done that one.
if you need to be too precise in your like frequency, then we need to run everything like simulation.
See, if the number of parameters are more, to get the result is not that much easy, sir.
So for particular screening based, it is nothing but it will just based on your design parameters only it will look at. Okay, and if it is multi-object, like for an example, if you have an antenna, with that single parameter you will be going with screening here. If you are going for with ground plane also, I am going to play with that. Let's suppose I am not going to play with a single parameter then. If I am going to play with the ground plane, the patch, the substrate dimensions, everything. So in that particular case, I will go for multi-objective genetic algorithm. So for every kind of case, we have different kinds of algorithm. Generally, I would suggest generic algorithm if you are blank and if you want to go for optimization. This particular random search algorithm or pattern search if you want to attain particular radiation pattern, or based on your frequency sweep data, this particular pattern search algorithm will be working on that.
Do we have any reference regarding these algorithms and all in ANSYS manuals something?
You can search it in help here. Directly you will get a PDF.
Okay.
In this PDF, any kind of HFSS scripting if you need, or guide based on all kinds of antennas or matching networks, you will be getting here. So this array, now just I will create a copy of this for reference. I will keep that just to compare what is the gain improvement which it has been done there.
So and also for polarization, like is there any other way to know the polarization?
Polarization parameters, actually we used to
I Google it, say like go through the surface current or
basically how it is.
E field pattern.
Hmm.
So based on the E field
The
lines,
space I
you have to go. Is there any precise way to do that?